Hi, my name is Aaron Estrada, one of the systems engineer at VECTOR-SARDF, a team that develops a UAV-based direction finding for search and rescue. All aircraft in the United States were equipped with an emergency locator transmitter, or ELT, tuned at 121.5 MHz, such as this. ELT is designed to help search and rescue people to find and save people who are in distress, especially if an aircraft crashes somewhere. Organizations such as the Civil Air Patrol are tasked to triangulate and locate these beacons using a handheld device such as this called a little helper. But these methods will require a lot of operator skill and time to try to find the estimated location of the beacon. With our product, VECTOR-SARDF offers a more efficient and much reduced search time in order to find this beacon. Right now, we're going to do a flight sortie where we will test our drone equipped with our algorithm and our payload. For this test, we're not going to use an ELT, but we're going to use a practice ELT tuned at 121.775 MHz provided by the Civil Air Patrol. All right, so we're at the field and we're going to do a flight sortie. The main objective of this flight sortie is to try to triangulate a practice ELT beacon that is positioned somewhere on this field by using the log RSSI values gathered by our software-defined radio and the GPS coordinates of our drone. So I'm going to set up the drone. I'm going to put a 3S battery that will give us about a flight time of 10 minutes. Right, so here's our mini ground station and we're going to do a flight. I've already uploaded a pre-planned flight plan using Cube Ground Control to do autonomous flight of the 3 expanding squares to triangulate the practice ELT, as well as I've already run a GNU radio Python script that enables the RSSI log and GPS log. With that, let's fly. Clear prep!
Armed. Cleared.
All right, so that's our flight. The next part is to do a post-signal processing to estimate the location of the practice ELT beacon. Our system uses an SDR to collect RSSI while logging GPS during the drone's flight. Each point represents signal strength at a known location. We process this in MATLAB to identify RSSI gradients and generate lines of bearing. The intersection of these lines gives the estimated ELT location. When compared to the true beacon position, the system achieved an error of about 15 meters. We evaluate accuracy using circular error probability. For the 50% circular error probability is 31.2 meters. For 90% CEP, 56.8 meters. This result is well within both bounds, confirming reliable localization. Finally, we export the CEP90 region to Google Earth, allowing first responders to focus on a small, high probability search area instead of scanning the entire field.